giving the head of a single linked list return true if it is palindrome. So what is palindrome? Palindrome is a sequence. If you read it from left to right or right to left, it's going to be the same. So as you see in this example, 1 2 2 1, or if you read it from right to left, still is going to be 1 2 2 1. But for the second example, if we read it from left to right, it's going to be 1 2, and if we read it from right to left, it's going to be 2 1, which is not equal. As you see, we return true for this one because it's a palindrome, and for the second one, we are going to return false. So the question is saying it's going to be a single linked list, so it's not a double linked list that we can go all the way to the end of the linked list and compare these two one by one. This is a single linked list, and we can only go from left to the right. What we can do here, we can go all the way to the end and reverse half of the linked list and then compare the nodes one by one. For doing that, first thing we need to do is to know what's the length of this linked list. So we are going to use 2 pointers, get the length, use 2 pointers, and reverse second half of the linked list, and then at the end we are going to compare them. So let's see how we can do that. I'm going to put some examples here, so it's going to help us for do the coding better. So let's first thing first, we need to get the length of the linked list. Getting the length is going to be very easy, so we are going to have a variable length. We are going to equal that to 0, and because we don't want to lose the head, we are going to store it in current. We are going to say while current, as long as we have a value in the current node, we are going to add 1 to length, and we are going to move forward. This way we are going to get the length of the linked list. After getting the length of the linked list, we need to deal with two situations. If the length is odd or even. If it is even, something like this, so we are not going to have a value like this one in the middle. These two are both palindrome, but this is even length and this is odd length, and we cannot compare these three with anything. We can just like jump from this and compare them. So for making everything easier, what we are going to do, we are going to find the middle for odd and even separately. So what I mean by that, we are going to say if the length that we have, the remaining divided by 2, if it is equal to 0, we know this is an odd case. So the middle is going to be just the length divided by 2, right? So the length is 4 divided by 2 is 2, so it's going to be 1 2. So we are at the middle, in the middle. So and we are going to have a mid 2 as well, because we are going to have 2 pointers. So one mid is for the first pointer, another mid is for the second pointer. So I can put one here, so it's going to be easy to understand. But for the case that we have even length, mid 1 and mid 2 are going to be the same, right? And for the case that is not, the length is not even, we are going to have an odd length, and we are going to say the length is going divided by 2 plus 1. So as you see here, by this plus 1, I'm jumping over this value here that we cannot compare it with anything. It's just in the middle. And the mid 2 is going to be mid 1 minus 1. So after finding the location of the pointers, what we need to do, we need to move the pointers to the right position. So I'm going to set for second pointer, right? We are going to set the second pointer. Second pointer is going to start from the head, and we are going to say while mid that we have here, mid 1, is bigger than 0, right? What we are going to do, we need to make the second pointer to point at this one, right? We need to make sure that it's pointing. Let's for easy understanding, I'm changing these two, so it's going to be much easier to understand. Okay, here. So the second meet set for the second pointer. So what we are going to do, we are going to say as long as meet is bigger than 0, we are going to move the second pointer one step forward. So P is going to be P2 dot next. So it's going to move one step forward, and we are going to meet2 minus 1. Sorry. And there you go. After we are done with this, the second pointer is going to point at this one. For this case, P2 is going to be here. And for this case, P2 is going to be here. As you see here, we are going to add +1 that, because when we get the middle, is going to be pointing at this one, right? 1, 2 is going to point at this one, and we are going to +1 that, so we make sure it's pointing at the right one. So the pointer 2 is pointing at that, and then we make the second pointer. We are done with the second pointer. Now we need to set the first pointer. We are going to set the first pointer, and we are going to reverse that at the same time. Okay, we are going to set the first pointer, and we are going to reverse that. For reversing, we need to know the previous and next node. We're going to set them to none, and we're going to store the head somewhere. So what we are going to do, we are going to say as long as mid1 is bigger than 0, right? What we are going to do, we are going to store the next node somewhere, which is going to be current dots next. So, which is going to be, for this case, we are starting from the head, right? So the second, the first pointer is pointing at this one. So the next one is going to be 2, right? And then current dot next is going to point at the previous one. We are just reversing it, and previous is going to be current, and current is going to be the next node, and we are going to minus this one, and that's about it. And finally, pointer 1 is going to be the previous one, which is going to be number 2 here, right? After we're done with this, now the first pointer is pointing, this one is gone, this is going to be, after that while loop, this is going to be like this, and this one is gone, and this is going to be like this. Now the first pointer is pointing at these two, and the first pointer for this one is pointing at these two. And now what we are going to do, we are going to check if it is palindrome or not. We are going to say while P2, we are checking if P1.val is not equal to P2.val, and if they are not equal, we are going to return false. Otherwise, we are just going to move them one step forward. And at the end, if we are done with this while loop and we don't get false result, we are going to return true. So let's clean this here, and let's run the code and see what we get. There you go, we get true. As you see here, we have done this in linear time complexity and a constant space complexity. Thank you.